right? Means routers are exchanging hello message with their own router ID. There is no
Yes.
active neighbor filled in hello packet. The next state was
Two-way.
Two-way.
two-way state. In two-way state, router see their own router ID in the hello message. And one more thing happens. This is very important state. What is that?
I can't see your screen.
D-
DRN,
where
DR and BDR
are
selection.
elected, yeah.
DR and BDR election. Why DR and BDR election happens? Why DR and BDR?
Avoid, avoiding for flooding. That's why that BDR DR concept.
Avoiding flooding. Flooding for what?
LSA flooding.
LSA
Flooding,
flooding.
yes. And to reduce number of adjacency. Usually in the data center network, you will see 50 number of routers in one VLAN. Let's say 50 routers are there in one VLAN. It means how many adjacency are there? For 50 routers belongs to one VLAN, let's say. One VLAN means
That will
one
be
broadcast domain.
250 to no
That is going to be
2500
1225.
agents. Yeah.
Right, so if you have 50 router in one broadcast domain means one VLAN. There you will have 1225 adjacency, the full adjacency. Whenever any change will occur, all the routers are going to Haruna, put yourself on mute,
Updates.
getting noise.
Okay.
Yes, whenever any change will occur, all the routers are going to generate LSA1 and they will flood LSA1 to their all adjacent neighbor. That is the flooding issue. That's why DR router and BDR router is required in broadcast network. Then next state was what? X start state. What happens in X start state?
To check
Router
the
exchange type 2 message.
bidirectional connectivity.
Router exchange type 2 message. Type 2 message is DBD, but empty DBD. Why? For sequence number exchange and for master and slab election. For two purpose, master and slab election and sequence number exchange. See, if router is only sending hello message, it is not receiving any hello message, it means the interface status is down. As soon as router is going to receive hello message over here, state will move to init. As soon as router will see their own router ID in the hello message, state will move to two-way. In two-way state, actually routers check their own IP address, see their own IP address in the hello message. Then one router will become DR and BDR election happens. After that, state move to X start. In X start, what happen? Router exchange.
Empty DVD.
Yes, empty DBD message. Sometime interview can ask you questions like this also. Type 2 message, routers exchange type 2 message in which state? Like here in two-way DR BDR election happens. After that, in X start state, router exchange DBD. Both the routers are going to send DBD. That is empty DBD. What is DBD?
Database description.
Database description. And master and see, two things will happen: sequence number exchange and master and slab election. Also MTU checks sequence number. Router is going to exchange sequence number in this state only. Router 1 is going to tell to their neighbor that, bro, my sequence number is 5. Okay, and the router with higher router ID will become master router. And MTU check. If you want, you can ignore the MTU check as well. Why master and slab election happens here? Master and slave. What is the purpose of master and slave? You know the purpose of DR and BDR. Now tell me the purpose of master and slave.
Who will send the first DBT pack?
Yeah, who will start talking first or exchanging database first? Which router will start exchanging database or start or initiate the database exchange? Master router. Which router will become master router? Router with highest router.
Higher
Yes,
ID.
router ID. Right? So the router who has highest router ID will talk first during database exchange, and then in exchange state, then state move to exchange. In exchange state, what happened? Router
Summary
exchange
LSA.
actual DBD. Yes,
Yes.
summary LSA,
LSA.
database description packet exchange. But this is summary LSA, or you can say link state database summary. What you can say? Link state database summary. You know the meaning of link state. The routing protocol, all link state routing protocols can view the entire topology. It is similar like your Google map. If you are going to search a destination, you will go Google map, it is going to show you all possible path, right? With cities, roads, and you can replace city by router, road by link. Okay, like this. Okay, again, this is not the detailed information of prefixes. Now when router will send request message in which state? In loading state.
Loading.
Then router will send
Loading.
the actual
LS request.
database.
LSR.
Yes, so in loading state, LSR.
Sir, in exchange still it will be type 2 LSA, right?
Yes, LSU and LS
LS.
act.
Act.
And once database got exchanged, state will move to full, and after that router is going to run SPF algorithm on their database, and it will calculate routing table. This was our state. Yesterday we had discussed this. Close it. So we have discussed how many types of messages? 5 types of messages. If I will talk about the database, right? Many times I said link state database. Guys, database is nothing but LSA. LSAs. Different types of LSAs is called link state database. And the very first LSA is called, or you can say these LSAs are nothing but LSU packet, link state update packet. Okay, LSAs. The first type of LSA is type 1 LSA, is called router LSA. Each and every router in OSPF domain generates this LSA, router LSA. But issue with router LSA is, you know what? Router LSA cannot cross area. Now here we are touching the area concept as well. Okay. For now, just keep in mind router LSA cannot cross area. I am going to talk about router LSA, type 2 LSA. Type 2 LSA is called network LSA. Only DR router generate this LSA. Then type 3 LSA. ABR router generate this LSA. Summary LSA. Then type 4 LSA is called ASBR summary LSA. Then type 5 LSA. Type 5 LSA is called
External LSA.
external LSA. Then type 6 is MOSPF LSA. No need to learn here. Type 7. Type 7 is NSSA external LSA. These are the LSAs which we need to understand. Now let's understand all the LSAs one by one. First of all,
This LSA will be exchange in exchange state. All these LSAs will be exchange in exchange state only.
loading state, loading.
Sorry, loading state. Yeah, sorry, loading state. Okay.
Yes. Now all the odd number LSAs, like you can see, router LSA, summary LSA, external LSA, and NSSA LSA. All the odd number LSAs, LSA 1, 3, 5, 7. Odd number LSAs are used to share the network information, prefix information, right? Like EIGRP routing protocol. Why we are running EIGRP between router? So that routers can exchange routing table, means network information, prefix information. Here your odd number LSAs are used to exchange the network information, share the network information. And all even number LSAs like LSA 2, LSA 4, LSA 6, these LSAs are used to share the, are not used to share the prefix information. There are some other function we'll discuss. Sometime it can share the IP address of some router, right? Means share the router information, not the prefix information. Okay, no worry, you will understand this. Now understand one thing what I had told you, that each and every LSAs will have two things. There will be two things or two informations in every LSAs, in each and every LSAs. What is that? Number one, link ID, or number one I can say advertising router ID, and number two is link ID. Number one advertising router ID, number two link ID. All the LSAs will have these two information. Okay, advertising router ID will be always the router ID of router who is advertising that LSA, who has generated that LSA. And link ID, sometime link ID can be your prefix information, prefixes means network information, it can be prefix, sometime it can be router ID. We'll see in which LSA link ID is going to be router ID. Like yesterday we had discussed, we had seen router LSA. In router LSA you had seen the link ID was what? Router ID. And in some LSA it can be IP address. Advertising router ID will be the always router ID of router who is advertising that LSA, and link ID can be prefix information, it can be router ID or IP address depending on types of LSA. We'll discuss that. Now I am going to start with our first LSA, that is router LSA. Router LSA. I said OSPF is a link state routing protocol, and link state routing protocol can see the entire topology. You know how that is possible? That is possible with the help of router LSA only. OSPF can generate or can view the topology within the area, because what I told you, router LSA cannot cross the area. It means router cannot see the topology between area, right? This is limited to area. Router LSA cannot cross area, and router LSA is actually all the networks or all the links connected on router, the information of all the links connected on router. For an example, I have router 1 here. This router has some LAN 10.1.1.0, 10.1.2.0 and 10.1.3.0. It is going to store the detailed information of these links in which LSA? In router LSA. Like in the router LSA of 1.1.1, you will see there are 3 links. You will see there are 3 links and there will be the detailed information of link. So about router LSA, keep in mind each and every router generates a router LSA in OSPF domain, but router LSA or LSA1 can be flooded within the area. LSA1 cannot cross area. For an example, I have 2 routers. Let me take simple example R1, R2. Both are connected like this, directly connected with each other through a point-to-point link. R1, R2, here 1.1.1 loopback and 2.2.2.2. If we have one loopback on both the router, then the IP address generating on loopback will become what? Router ID as well. Here IP address is 12.1.1.1. Here IP address is 12.1.1.2. So if I will talk about the router LSA of R1, see in this OSPF domain, how many router LSA will be there? 2 router LSA, 1 router LSA of R1, 1 router LSA of R2. If there are 2 routers in my OSPF domain, both the routers are going to generate router LSA. I told you each and every router generate router LSA in OSPF domain, and both the routers are going to exchange router LSA as well. So if you will check the database of R1, you will see 2 router LSA. In the database of router 2 also 2 router LSA. OSPF database is going to be identical, same, right? The database of R1 and R2 will looks exactly same. It is linked. That is the meaning of linked state routing protocol. Both the routers has same information. So there will be 2 number of router LSA. Out of that, if I will talk about the router LSA of router 1, router LSA of router number 1, LSA 1, how it is going to represent their LSA with router ID 1.1.1, means this is router LSA of 1.1.1 of router whose router ID is 1.1.1. After that, what I told you, every LSA will have these 2 information, advertising router ID and link ID. What will be advertising router ID here? Advertising router ID is going to be 1.1.1.1. The router ID of R1, because R1 is advertising this LSA. And link ID will be also what? Link ID will be also the router ID of R1, right? So here you can see in router LSA, link ID and advertising router ID, both is going to be what? Router ID of router who is generating that LSA. Then there will be detailed information of links, like link 1, or yes, I can say like this, link 1, network 12.1.1.0, cost let's say 64 on the serial link. Then link 2, network 1.1.1.1, cost let's say 1. Then it is going to consider their neighbor also as a link. Link 3, 2.2.2.2, and whatever cost it will calculate to reach this neighbor, let's say to anything. This is what router LSA of router 1. Similarly, router 2 is also going to generate their router LSA, and after that both will exchange. In exchange state, router will only send the summary information, means header, and router number 2
How you have taken the cost?
Hmm?
Cost 6412 like that.
I have just taken random number.
What?
Any random number.
Okay.
So Praphul, the advertisement router ID and the link ID are always the same, or there are some situations where they're different?
No. Sometimes see, advertising router ID will be always same, but link ID can be router ID, it can be IP address, it can be prefix information. In router LSA, it is router ID.
It just depends on the equipment,
Correct.
the router.
In this topology, tell me how many router LSA will be there in the database of any router R1?
3.
3. Here I have configuration of all the routers. Let me show you R1 configuration. R1, here I am going to enable OSPF also, router OSPF 1 and router ID 1.1.1, then interface G0/0 IP address 10.100, and on G0/1 IP address 12.1.2. On 0/1 I am going to enable OSPF IP OSPF 1 area 0, and let me change the network type also, IP OSPF network point to point. Okay, let me copy these two commands and let me run it on other interfaces as well, like on G0/0. But on G0/0 network, this command is not required. Let me remove it. Okay, now you can see R1 configuration is done. Let me copy the commands and let me paste it on R1. Enable and paste.
Praphul, can you copy this command in chat, please?
Copy this command in chat.
Yes.
Copy this command in chat. What is
Whatever you have configuration command in chat box.
Okay, so IP OSPF interface brief. Here you can see now OSPF is enabled on G0/1 as well as on G0/0. To avoid DR and BDR between routers, I have changed the network type from broadcast to point to point. So here you can see DR BDR election is not going to happen. Okay, and I can configure this interface as passive interface, right? Because this is my LAN interface. Similarly, now I am going to configure R2. On R2 also, first let me enable OSPF, router OSPF 1, and router ID is going to be 2.2.2 on R2. 2.2.2.2, and let me enable OSPF on both the interfaces on G0/0 and 0/1, 0/0 and 0/1. On G0/2, 0/2 is my LAN interface of R2, so IP OSPF 1 area 0. Just I have enabled OSPF. Let me copy the commands of R2. Let me paste it on R2, router number 2. Now I am expecting OSPF neighborship between R1 and R2. Fail to allocate router ID. I think we have configured router ID manually. Okay. Now neighborship is up, so IP OSPF neighbor. Done. And if you will check database, so IP OSPF database, then you can see how many router LSAs are there. This is router link state, router LSA, means LSA 1, right? I am checking the database of router 2, 2.2.2. This is database of router 2, and in the database of router 2 you can see there are 2 number of router LSA. This is the router LSA of router 1, this is the router LSA of router 2. Similarly, on router number 1, so IP OSPF database, you can see so IP OSPF database. We have exactly same database. Again here I have 2 router LSA, router LSA of router 1 and router LSA of router 2. In the router LSA of router 1, how many links are there? 3. But tell me guys, on router number 1, you can see how many links are there? Only 2. Then how it is counting 3 here? It is considering their neighbor also as a link. So one is G0/0, one is G0/1, and one is their neighbor. Router number 2 has 4 link. You can see 3 link, 0/0, 0/1, 0/2, and 1 neighbor. So total 4 links are there. Databases you can see exactly same. On router number 2, so IP OSPF database, and so IP OSPF interface brief. You can see OSPF is enabled on all the interfaces. On G0/1 and 0/0, network type is point to point. Now let me configure R3. On R3 also, first I will enable OSPF. Copy this command. Let me paste it over here. Router ID is going to be 3.3.3.3, and let me use copy these two command to enable OSPF on G0/0 interface, and on G0/1 IP OSPF 1 area 0. This is R3 configuration. Let me copy it and let me paste it on R3. Let me access. Now host name is changed. Done. Now we have enabled OSPF on all the interfaces. Here also you can see neighborship is full. So IP OSPF neighbor, and so IP OSPF neighbor. Here now if you will check database, so IP OSPF database, then you can see 3 number of router LSAs are there. It means 3 routers are there in my OSPF domain. If you have 10 routers within the area, you will have 10 number of router LSA, because we know each and every router in OSPF domain generates router LSA 1. Router LSA carry the detailed information of link, the state of link.
Sir, I have doubt here. Sir, how, like, you have not configured anything like network command, right? So, how router to?
Is it your first class?
No, sir, second class.
Yesterday I had told that there are 2 ways to enable OSPF on the interface of router. One through network command, one on interface basis.
Okay.
So type 1 LSA is router LSA generated by every router inside the area. Router LSA cannot cross the area, and router LSA describe interfaces like what is the cost on interface, which subnet is running on the interface, and neighbor information. But here I don't
Sir,
have any
but
network.
router 3 showing only 2 links. It should be also 3, right? You have not put at the router command, OSPF command
So
on the LAN
IP
interface.
OSPF neighbor, so IP OSPF interface brief. This interface is down. That's
Is
why.
down. Okay, because of that.
No shutdown. So IP OSPF database. Now see. Okay, sir.
Yes.
And here is the sequence number of router 1, sequence number of router 2, sequence number of router 3, router LSA. Checksum is advertising router ID and link ID. You can see in all router LSA, link ID and advertising router ID both are the router ID of router who is generating that LSA. We don't have any LSA 2, LSA 3, 4, 5, no any other LSA. Only router LSA are present in the database. And if you will check any router database, even R1 database, you will have same information. You can see here. Is there any difference between router 1 database and router 3 database? No. This is the meaning of link state routing protocol. Even if you will give me only console of R1, and if you will ask me to design the topology, I can design the same topology. Do you guys want to see? Just by looking into this database, I can design this topology. OSPF can design this topology. See how. First, router 1 is going to run this command. So IP OSPF database. What it will understand? That there are 3 routers, correct? In my area, 3 routers are there. I am 1.1.1. First, router is going to open their own database. Okay, I am one router and my router ID is 1.1.1. My router ID is 1.1.1. Now you know what router 1 will do. Router 1 is going to open their LSA 1 in detail. So IP OSPF database and then router LSA, and you will always open database with link ID, not advertising router ID. If I want to open this router LSA in detail, I will use this link ID 1.1.1.1. Here, see how many links are there? There are 3 links. Right here you can see link ID and advertising router ID. This is actually LSA header. This is called header, LSA header. And here is the link information. See 3 links. Link connected to another router through point-to-point link, and neighbor router ID is 2.2.2, and my IP address to reach the neighbor, like on my interface IP address is 12.1.1, and metric not there. Okay, it is talking about one neighbor router. My neighbor router has router ID 2.2.2. It is talking about R2. It is talking about R2. Then metric 1. Okay, metric to reach this neighbor is 1. And one more thing, my interface IP address is 12.1.1. Then link connected to stub. Stub means directly connected network, LAN network. A link connected to a stub network means it is LAN network. Stub network means connected network, and network ID is 12.1.1.0. Here IP address is 12.1 and here subnet is running 12.1.1.0. It is talking about the subnet between R1 and R2. Subnet mask 255.255.255.0 and metric is 1. Okay, the network which is running over here is 12.1.1.0/24. It knows the subnet mask as well as cost. Cost of this link is 1. Then another stub network, another directly connected network where network ID is 10.1.1.0, subnet mask 255.255.255.0 and metric is again 1. It is talking about the LAN connected on router number 1 only.
But it didn't tell the interface.
No, didn't tell the interface. 10.1.1.0/24. And what is the metric? Metric over here is also 1. Cost. Interface ID doesn't matter for best path selection in any dynamic routing protocol. Cost value 1. Now, is there anything else in the router LSA of R1? No. Router can view these things by looking into their own router LSA. Now router 1 is going to open router LSA of 2.2.2. In the database, here is the router LSA of 2.2.2. 5 links are there. It will open this router LSA. IP OSPF. So IP OSPF database router LSA 2.2.2.2. Okay. The router ID, router 1 already know the advertising router ID and link ID. Now link connected to a stub network. Router 2. Right, router 1 is checking router LSA of router 2. Router 2 is connected with one stub network where network ID is 20.1.1.0. This is the subnet mask and here is the cost. It is talking about the LAN connected on router number 2 with subnet 20.1.1.0. 20.1.1.0/24 and cost is again 1 here.
Sir, here I have one question that when we are opening the LSA 1.1.1 detailing, there is a two sub network, right? One is 12 and one is 10. Am I audible, right?
A stub network, not sub network.
No, stub network, yes. So this is directly connected. So how do I find out which one is for connecting to R2 or which one is for LAN? Because both information are exactly the same actually.
You can understand. See, so IP OSPF database router LSA and 1.1.1. What it's saying? Connected to another router with point to point. So with the help of this IP address, you can understand it is talking about the subnet between R1 and R2. OSPF is more intelligent than you. Okay.
Okay, sir.
Now router OSPF database router 2.2.2 router LSA of 2.2.2. Okay, it is talking about the LAN. Here metric is again 1. Now connected to another router, again point to point, means it is talking about another neighbor. Router 2 has one more neighbor and router ID of that router is 3.3.3 and IP address of R2 is 23.1.1.2. It is talking about R3.
It's at R2 that it's talking about. Or R3.
Router ID 3.3.3.3 and IP address over here is 23.1.1.2. And what is the cost? 1. Cost over here is 1. Then again link connected to stub network 23.1.1.0. Here it is talking about this network 23.1.1.0/24. Metric is again same 1. Then link connected to another router point to point. It is again talking about neighbor. Okay, it is talking about R1, right? In the database router LSA of R2, here you can see the information of neighbor R1. So okay, it is talking about myself. IP address of R2 is 12.1.1.2. Here IP address is 12.2 and metric 1 we have already mentioned. Then link connected to a stub network where subnet is 12.1.1.1.0. Again it is talking about this subnet only, right? See, the information of 12 subnet is present in the router LSA of R1 as well as in the router LSA of R2. By looking into the router LSA of R1 and R2, router can view this topology. Only one thing is pending, that is stub network connected on R3. For that, router 1 is going to open router LSA of R3. So IP OSPF database and so IP OSPF database router 3.3.3.3. Okay, router 3 has also 3 link connected to a stub network where subnet is 30.1.1.0. It is talking about the LAN only. (30.1.1.0/24) and metric cost is again 1 here. Cost is 1. Link connected to another point to point router ID 2.2.2. We have already discovered this. IP address of R3 is 23.3. Here IP address is 23.3. After that, another stub network with subnet 23.1.1.0, right? It is talking about this subnet only and metric is 1. See the entire topology. I have not checked the database of router number 2. I have not checked the database of router 3. I have just checked the database of router 1. So router 1 can see the entire topology, but within the area, because detailed informations are shared with the help of router LSA only. Router LSA only carry the detailed information of link. That's why we are saying OSPF is pure link state routing protocol within the area. Between the area, OSPF works as a distance vector routing protocol like EIGRP. They only exchange routes, not the complete information of topology.
Can we just follow up a little bit? One. There is one question that the link ID, it must be the router ID, it must be the prefix or IP address. So right now we see that it is considering the router ID as a link ID. So which is there any specific condition to for that the prefix and the IP address?
Wait, understand all the LSAs first. You will learn
Okay,
it.
okay.
Okay. Now let's move to network LSA. LSA 2. Type 2 LSA. Network LSA. Which router generate network LSA?
DR router.
DR router. Why? No one have
Because
idea?
it has detailed information of the neighbor, right? DR router. Because neighborship is formed between with the all the other router will be formed neighborship with the DR router.
See here what happened. All the router has 3 number of router LSA in their database. If there will be any change, if I am going to add any prefix on router number 1, first router 1 is going to update their router LSA. It will send updated information to router number 2. Router number 2 will share to their neighbor, right? See here, I can show you once on router number 1. So IP OSPF database. See, how many links are there? 3 links and sequence number 3. And so IP OSPF include SPF. How many times it has executed SPF algorithm? 4 times.
4 times.
On router number 2 also you can check it. How many times?
Is the answer to prevent flooding 4 as well?
Wait brother, wait, let me finish. 4 times. And so IP OSPF database sequence number is 4. Even you can check sequence number in any database of any router. Sequence number is going to be same 4. 4 is the sequence number of router 2, 3 is the sequence number of router 1, and 3 is the sequence number of router 3. And it has also executed their SPF algorithm 4 times. Let me check R3. How many times R3 has executed their SPF algorithm? 2 times. Now let me take you to R1. Config T, interface loopback 1, IP address 10.1.10 192.168.1.0/1.0 and IP OSPF 1 area 0. What happened? OSPF will not operate on this interface until IP is configured. Bad subnet mask, let me say 1.1, and after that IP OSPF 1 area 0. So IP OSPF database. See, sequence number of R1 is 4, and how many times it has executed SPF algorithm? 5 times. Sequence number of R2 is still 4, but check how many times it has executed SPF algorithm? 5 times. And router number 3 times. So whenever any change will occur in the topology, all the router within the area will execute the SPF algorithm. And it was creating issue when I have lots of routers, multiple routers, more than 2 routers in one broadcast network, like in this topology. In this topology, all the router has 3 neighbors. So if any change will occur, all the routers are going to update to their all neighbor, and when neighbor will get updated information, they will also update to their neighbor. To avoid flooding and lots of adjacency, here we will configure DR and BDR. Now let's suppose R1 is my DR router. R1 is my DR router and all other routers are DR other. DR other. R4 or 3 is also DR other. DR other. DR other will have neighborship till two-way state, right? Router 2 and router 4 will only have neighborship till two-way state. So in this network, in this type of network, when we have DR router, then DR router always generates network LSA to share the information of connected router in this broadcast segment, in this multi-access segment. Means router number 1 is going to tell to router number 2 about all other connected routers in this network. We know the DR and BDR election, but here I don't want DR and BDR election should happen on default, otherwise router 4 will become DR router, because on router number 4 I will configure router ID 4.4.4. So I don't want router 2, 3, 4 should become DR. What can I do?
Change the priority to 0.
Priority.
No, I want it should participate. Router 2, 3 and 4 should participate. If you don't want to participate them, definitely you can configure priority 0. But if I want to participate but should not become DR, only R1 should become DR, I can configure higher priority and enable OSPF first on router number 1. For now, let's do priority 0, and here my segment is 192.168.1.0/24. On router number 1 I will configure .1, on router 2.2, on router 3.3. let me use notepad for configuration. In config t interface F0/0, no shutdown, and IP address 192.168.1.1, 255.255.255.0, IP OSPF1 area 0, exit router OSPF1 and router ID 1.1.1, exit. Let me copy it, let me paste it on R1. For R2, IP address is going to be 1.2 and router ID is 2.2.2. Let me copy and paste it on R2. For R3, IP address is 3 and router ID is going to be 3.3.3. Let me copy it and let me paste it on R3. And on R4, IP address is 1.4 and router ID 4.4.4. Is preemption enabled for DR router? Will preemption work? Like if any other router is going to become DR and later when any other router will come with higher priority, will that router become DR?
No.
No. Right? So for DR router, preemption don't work. Remember that. See, here network type on Ethernet link is by default broadcast only. On broadcast network type, DR BDR election will happen, and let me see which router is the DR router. So IP OSPF neighbor. Which router is DR router? One minute, sir.
Router 4.
Which router is the DR router? R4 is your DR router. Why? Why R4 is DR router? Because R4 has
Highest router
highest
ID.
router ID, because priority is by default same on all the router. Okay, and who is BDR? Router 3, who has second highest router ID. Okay, if I will configure priority 0 on router number 4, because I don't want router 4 should be my DR. So let me configure priority 0 here. It will not participate in DR and BDR election. Interface F0/0 IP OSPF priority 0. Now which router will become DR? Your BDR. BDR router will become DR. Here you can see, and router 2 is going to become now BDR. Soon router 2 will become BDR. Here you can see router 2 is the BDR, router 3 is the DR. I don't want router 3 should also become DR or BDR. Interface F0/0 IP OSPF priority 0. Now router 2 will become DR and router 1 will become what? BDR. So that's why now router 1 has full adjacency with all the router, but router 2 is the DR. I don't want that also. Router 2 should also not participate in DR BDR election. Go to F0/0 and say IP OSPF 1 area 0. Now see router number 1. So IP OSPF neighbor. Router number 1 is the DR router. That's why it has full neighborship with all other routers. Router number 1, sorry, let me take you to R1. So IP OSPF neighbor. Router number 1 is the DR router. That's why it has full adjacency with all other routers. 2.2.2. 2.2.2 is DR. Router 1 is not DR. So IP OSPF interface brief. So IP OSPF neighbor. So IP
Sir, in router
OSPF
2, you are
interface.
not configured the priority.
Priority is not, yeah.
Config T interface F0/0 IP OSPF priority 0. Wait for a minute. Now you can see R1 is the DR router and it has full neighborship with all DR other. On router number 2, so IP OSPF database. Sorry, not database. So IP OSPF neighbor. You can see router 2 has full neighborship with DR router and neighborship without adjacency with router number 3 and router number 4. Router number 3, similarly all the router has full neighborship with R1 and neighborship in two-way state with DR others. On R4 also, so IP OSPF neighbor. Got it? You know how DR BDR election happens here? Based on priority. Priority on router number 1 is 1 and priority on other routers is 0. See here, again all the routers are going to generate router LSA. All the routers are going to generate router LSA, LSA1. LSA1 of router number 1 will have link ID 1.1.1, advertising router ID 1.1.1, and then link information link 1, link 2, like that. Similarly, all the router is going to generate router LSA. And router number 1, which is the DR router, will send their router LSA to all other router because they have full adjacency. But DR other, like router number 2, can only send router LSA to DR, to R1, and R1 will flood that to other neighbors. If I will capture this link for a moment, and if I will show you the hello message, hello message only. Here you can see which router is sending this hello message. DR other. DR other is sending hello message on which address? On .5. DR other router, and DR router is also sending hello message on which address? .5. So that every router can listen this hello message. Every router listen on .5. All OSPF enable interfaces join this multicast group. Now on router number 1, if I will add any prefix, go to router 1, say interface loopback 1 IP address, not on router number 1, on router number 2, on any DR other router. Interface loopback 1 IP address 10.1.1. or 20.1.1.1 255.255.255.0 and IP OSPF1 area, IP OSPF1 area 0. Enter. As soon as I will enter, what happen? Router 2 is going to generate update message. Which message? It is sending which LSA? Router LSA. To whom? To see on this multicast address 224.0.0.6. means this message is only for DR. Only router 1 is listening on this address. Even you can verify that through console. If you will check R1 fast Ethernet 0/0, so IP interface fast Ethernet 0/0 and include 224. You can see R3 has only joined this multicast group. But if I will show you R1, on R1, if I am going to run this command, then you can see R1 has joined both multicast group. It is listening on both address. R2 only listening on R1 only listening on .5. R3 only listening on .5. R4 only listening on .5. Right? So if any update message is sent on .6, that means DR other router has generated that for DR. And now in the next moment, DR router is sending update message on .5 so that other DR others, like other DR others, can learn this newly added prefix. So here you can see we don't have any flooding. If I will open it, you can see in the packet, in the update packet, LSA1, this is LSA1 header, and here is the prefix information, LSA type 1 router LSA. If I will open, you can see which prefix information is there, 20.1.1.1. I have added this loopback. And what it's saying? Metric information with prefix. Metric information with prefix. And then acknowledgement, okay. See here, in the broadcast network type, when you have more than 2 routers connected with same segment, then DR must be there. One router should become DR, other should be DR other, or you can have one BDR as well. And DR router generate LSA2 also to share the IP address of all other routers in this domain. Like how router 2 will got to know about the IP address of this router, like whatever routers are connected in this segment, how these routers will understand that. For that, DR router is going to generate LSA 2. You know, in LSA 2 what it will store? Advertising router ID. Advertising router ID will be what? 1.1.1. Which router is generating this LSA? DR. So router ID of DR router. And link ID. Link ID will be, you know what? Here. Link ID is going to be IP address of DR router 192.168.1.1. In router LSA, link ID was the router ID of router who is advertising that LSA. In LSA 2, link ID is going to be the IP address of DR router. And this LSA will carry the attached router information. Information means one router IP address, attached router means 1.1.1.
You wrote attacked. You might want to change them.
Three dot 3.3 and 4.4.4. This is what a router LSA. Only DR router will generate it. Remember, first time. If you will open database of any router here, let's say router number 4, so IP OSPF database, here you can see we have 4 router LSA because we have 4 routers and 1 network LSA generated by 1.1.1, which is my DR router, and link ID is the IP address of DR router. If you will open this LSA in detail, so IP OSPF database and network, and I told you to open LSA in detail with network ID 192.168.1.1, then here you can see there is nothing but attached information of router. Again, this is LSA header, and here is the attached router information, means how many routers are attached in this segment. It is going to share the router ID of all.
Praphul,
Yes.
please, I have a question. As the DR router is advertising LSA2 with all the the other links of other routers. Before you show that router 3 and 4 are on two-way estate, I want to know if the router are in two-way estate, can they still perform normal OSPF or they are stuck there?
Sorry, sir. If routers are in two-way state?
Yes, because you should you have seen that router 3 and 4 were in two-way state.
Correct.
Because yes, in two-way state, you said that normally that means that router are stuck in DR-BGR election.
No,
So
this is normal situation. This is not stuck. DR
okay,
other and DR other should have neighborship till two-way only.
okay. So that okay. Because before I thought that the state should be only at full to fulfill the OSPF completely, the database.
So when routers exchange database, then state move to full state. Here all DR other will have full state with DR router only. Right?
Okay.
All the DR other are going to share their database to DR router, and DR router will advertise to other DR other. It is like
Okay.
that.
Okay, thank you.
Sir, that DR other we have configured that loopback, and it goes to DR only, that .6 in multicast address. Then DR is multicast to others, means in .5. But the matrix is there. The matrix is 1. So for all routers, matrix is 1, or means that
All
matrix is
routers
changed
are
by
going
router?
to calculate the metric. All
Okay.
router will calculate the metric. It will add the metric which is coming in update, and metric of my receiving interface will be the total metric.
Okay, means the DR is sending that our matrix, then the other is calculating by their
Not
other links
DR is
only,
sharing
right?
their metric, bro. DR other router number 2 has shared the metric. Right here I have added the network
Correct.
20.1.20.1.1.0 or 1. Let's suppose router 2 has calculated the cost 1. So it is sharing the cost to DR. DR router is going to use the receiving interface cost, and cost coming in the update. So total cost is going to be what?
2.
2. So DR router is going to advertise with cost.
But when we see the packet capture on that,
No.
cost is only 1.
DR router is not going to use their receiving. It will use their receiving interface cost to calculate metric over here. On router number 1, you can see, so IP route OSPF. So IP route OSPF for 20 network, what is the cost?
2.
2. And what cost is coming in the update? 1. It will advertise 1 only with other router, and router number 3 is also going to use their receiving interface cost. So cost will again become 2 here on all DR other. So this is not the path. Like when router 3 want to send traffic to 20 subnet, it will send to router 1 first, and then traffic will go to router number 2. Traffic will go directly like this, so it will use this path cost only, not the cost of DR. Here if you will capture this link, this link, this link, on any link, cost is going to be 1 only, which R2 is advertising.
Okay, understood.
Now what if I have two area, router number 1, router number 2, router number 3, and let's say one more router number 4. We configure OSPF on interface of router, not on the router. So let's suppose in this scenario, on router number 1 and 2, I am running four. Here I am running OSPF area 0, or here I am running OSPF area 0, and this is my OSPF area 1. Area 0 and area 1. Here I have a LAN on router number 1, 10.1.1.0/24. So router number 1 is going to share this network information in form of LSA1. Router 1 will generate router LSA. It will send to their neighbor, to router number 2. But will router 2 send it to router 3? No, it cannot cross the area. So router 2 can learn this 10 subnet, but router number 3, 4 can never learn it. Similarly, here if I have a subnet 40.1.1.0/24, router 1 will generate LSA1. In that LSA1, it will carry this network information and it will advertise router LSA to their neighbor, to router number 3. Router number 3 will advertise to router number 2, but router 2 cannot advertise that to router number 1. How many router LSA will be there in the database of router 2? How many router LSAs will be there?
2.
4.
So router number 2 will have
Area 1,
router LSA in both the
area 1, right?
area 0 and area 1.
Area 1.
In area 0, there will be 2 LSA, router LSA 1.1.1 and 2.2.2. In area 1, there will be how many router LSA?
3.
2.2.2, 3.3.3 and
4.4.
4.4. So can 10 and 40 communicate? No. In that database of router number 1, you will have 2 router LSA in area 0, 1.1.1 and 2.2.2. Similarly, in the database of router number 3, you will have 3 router LSA in area 1, 2.2.2.2, 3.3.3 and 4.4.4. And router number 4 will also have same database, right? So see, 40 subnet is present in the router LSA of router 4, and router number 1 don't have this router LSA. Similarly, this 10 subnet is present in the router LSA of router 1, which is not available in the database of router 3 and router 4. So 10 and 40 cannot communicate with yes, cannot communicate with each other. Anyone have idea how we can make communication? Or even if you will configure, they will communicate. But based on our learning, what we have understood till now, router LSA and network LSA, based on that, these two different areas are not going to communicate. 10 and 40 are not going to communicate with each other. To understand the communication over here, you have to understand types of routers in OSPF. How many types of routers we have, guys?
we have ABR and ASBR, DR, BDR. So for this to work, you need those area border router and to be configured so it can exchange.
Okay. See, later we are going to categorize area into various categories, various part. For now, remember there are two types of area in OSPF. One is called backbone area and one is called regular area. Area 0 is called backbone area, and any area except area 0 is called regular area. You know the range of area 0.0.02 255.255.255.255. This is the range of area ID. So this area is called backbone area, and except this area, all other area means from 0.0.1 to 255.255.255. These all areas are regular area. Okay, area 0 is the backbone area, area 1 is the regular area, area 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 50, 100, 1000, 2000, all are regular area. One more thing I want to discuss before understanding this part. I am going to capture any link over here. G0/0. I have captured this link. Just I want to show you flag. On router number 1, I'm going to set the LAN interface. I'm going to no set the LAN interface so that it will generate LSA1 interface G0/0 shutdown. Here is your capturing. Why we have two capturing? This is old capturing. Let me close it. Here is my new capturing. Okay. Now on router number 1, again I am going to say no set command. No set. And see the router LSA. Here you can see router LSA of R1. If I will open this router LSA, open the open shortest path first message, open the header. In the header you can see we have header information like the version, same we have seen same information in the through CLI also. Close it and let me open the LSA update packet. In LSA update packet, here is a router LSA. If I will open, how many router LSAs are there? Only one. If I will open this router LSA, here you can see some flags. Out of these flags, now I am going to discuss B flag, E flag and V flag. Others flag like NSSA flag we'll see later. What is B flag, what is E flag and what is V flag? Soon I am going to tell you. But keep in mind that all router LSA has these flags, and by default you can see all these flags are 0, right? Not in use, all are 0. Now understand types of router. Okay. First type of router in OSPF is called backbone router. What we call backbone router. Router whose all interfaces belongs to area 0. Router whose all interfaces is in area 0 called backbone router. Second type of router is internal router. Router whose all interfaces belongs to regular area is called internal router. Router whose all interfaces are in regular area is called internal router. And here is the third type of router, a special router. Number 1, number 2, and number 3. ABR router. ABR stands for area border router. Area border router. Router whose at least one interface is in area 0 and at least one interface is in any regular area. That type of router is called ABR router. And the fourth type of router is ASBR router, autonomous system border router. Router whose at least one interface belongs to router whose at least one interface is in OSPF and at least one interface is in any other routing domain. Means one interface is in EIGRP, one interface is in OSPF, or one interface is in BGP, one interface is in OSPF. That type of router is called R1, R2, R3, R4, this is my one, 2, 3, 4, 5, 6, 7. Let's suppose here I am running area 0. Here I am running area OSPF area 10 and this is my EIGRP domain. Here I am running EIGRP. Tell me which type of router R1 is? Which type of router R1 is?
Backbone router.
R2?
Backbone router.
R3?
Also backbone.
R4?
R4 is
ABR.
internal.
ABR.
ABR, right? One interface is in area 0, one interface is in regular area.
Regular area.
R5?
ABR.
ABR.
R6?
ASBR.
ASBR.
And if I have one router here?
IR.
Internal router.
This router?
Internal
Internal router. IR router.
Whose all interface belongs to regular area.
Regular area.
Whenever ABR router generate router LSA, LSA1, it turn on E bit. Sorry, not E bit, B bit. B bit. What happened? Whenever ABR router generate LSA1, it turn on B bit so that router 1, router 2, router 3 can understand router 4 and router 5 are ABR router. Question to you is this: how router 1 will get to know that router 4 is ABR? Praphul, simple. ABR router turn on B bit in their router LSA. B bit is called what? Here also you can see B bit means area border router. So right now B bit is 0 because router is saying no, I am not area border router, I am backbone area or maybe internal area. If there is any ABR router that will turn on this bit, it is going to be yes. Are you ABR? Yes, I am the ABR router. Now we have discussed LSA 1, LSA 2, and here is your LSA 3. Let me replace the configuration over here. Between router 1 and router 2, I am going to configure area OSPF area 0, or what I can do here, I can create the topology, simple topology for area concept.
Sir, what is the difference between the regular area and the backbone area? Is there any specific definition here?
Definitely yes. Backbone area is, there is no any difference between regular area and backbone area. Both the area are same for now.
There are differences between backbone router and regular router, right?
Correct. Between backbone router and regular router, what is the difference?
The backbone area is the one that belongs to that has interfaces. No, that's the ABR. That's the
ABR.
ABR, right?
Correct, correct.
Okay, so that's a good question. I know that for sure that the backbone area belongs to always area 0.
See, this is my topology, and here I have area 1, and here I have LAN subnet 10.1.1.0/24, and here I have 40.1.1.0/24. LSA, what I told you, all the odd number LSA are used to share the network information. So LSA 3, or I can say like this, ABR routers generates LSA 3 to share inter area prefixes. What I am saying, ABR router generate LSA 3 to share inter area prefixes. Which router is the ABR router here? If this is my area 0 and this is my area 1.
Router 3.
Router 3 is the ABR router. If I will talk about the database of router number 1, sorry, of R3, then in the database, you know there are two area 0 and area 1. In area 0, there are 3 router LSA, and in area 1, there are 2 router LSA, 4.4.4.4, right? This is what? LSA 1. This is LSA 1. There will be no any LSA 2 because now I don't have any DR or BDR. Directly I am moving on LSA 3. Router number 3 is going to generate LSA 3. Let me write here. Router number 3 is the border router, and border router will generate LSA 3. It will generate how many LSA 3? First of all, ABR router will generate LSA 3 for both the area. It will advertise area 1 prefixes in area 0 and area 0 prefixes in area 1. So let's suppose it has generated LSA 3 for for area 0. For area 0. How many LSA 3 are required? See, LSA 3 is nothing but prefix information, not the detailed information of link. How many prefixes are there in area 1? 2 prefixes are there. 2 prefixes are there. Here you can see 40 and 34. So it will see here 31.1.0 and 40.1.1.0. These 2 prefix information in form of LSA 3. This is going to be, this network is going to be link ID, and advertising router ID is going to be 3.3. Link advertising router ID is 3.3.3. It means 3.3.3 has generated this LSA 3, and link ID is what? The prefix information. Link 1, then link 2, link ID 40.1.1.0/24 subnet mask, and the cost value. What is the cost from router number 3 to the?
Sir, I missed like where this 34.1.0 configured. Sorry, just missed it.
Between router 3 and router 4.
Okay, thank you.
Okay, so router 3, ABR router is only going to share network information, subnet mask, and cost from R3 to the destination. So for 34 network, cost is 1, and for 40 network, cost is 2. Let's say cost of loopback interface is 1, and cost of this interface F1/0 is also 1. So total cost is 2. LSA 3 can cross area. Router number 3 is going to send it to router 2. Router 2 will send it to router number 1. Now router 1 is going to learn these 2 prefixes, 34.1.1.0, 40.1.1.0. But question is, how R1 will calculate the cost, Praphul? How R1 will calculate the cost? So here you can see who is advertiser router, 3.3.3, and whenever router 1 will receive LSA 1 of router 3, it will receive with B bit on. It means router 3 is ABR router. Router 1 already knows what is the cost to reach ABR. So cost to reach ABR is 1 and 1, 2, and cost which is coming in the LSA 3 is 1 for 34 and 2 for 40. So in the routing table of R1, in the routing table of R1 for 34.1.1.0, cost is going to be
3.
What is the cost to reach ABR?
2.
2. Until and unless router don't know who is ABR, it cannot calculate the cost for inter-area prefix. That's why ABR router sends B bit on LSA 1, so that all the router in area 0 and area 1 can understand that R3 is your ABR router. So cost to reach ABR is 2, and 1 cost coming in the LSA 3. So total cost is 3. And for 40.1.1.0/24, what will be the cost?
4.
4.
It is going to be 4. This is how router is going to calculate best path or metric for inter-area prefixes. Similarly, router 2 will also generate LSA 3 for which area? For area 1. How many LSA 3 it will generate? For area 1, how many prefixes are there, Praphul, in area 0? Advertising router ID is the same. Link ID 10.1.1.0/24. 1 LSA 3 for 12.1.1.0, and 1 LSA 3 for 23.1.1.0. See, in network LSA, in LSA 2, what we have seen? In router LSA first, we have seen link ID and advertising router ID is going to be router ID of router. In LSA 2, we have seen advertising router ID is the router ID of advertiser router only, but link ID is the IP address of DR router. And in LSA 3, what we have seen, link ID is nothing but inter-area prefix. Inter-area prefixes. Got it? Let me configure this topology. Close it. R1, R2, R3, R4, R1 config T, interface F0/0, no shutdown, IP address 12.1.1, 255.255.255.0, interface F or loopback 1, interface loopback 1, IP address 10.1.1.1, 255.255.255.0, exit router OSPF 1, router ID 1.1.1. Then interface range F0/0 and loopback 1, IP OSPF 1 area 0 and IP OSPF network point to avoid DR and BDR. Go to router number 2 and say interface F0/0, no shutdown, and IP address 12.1.2, 255.255.255.0, interface F1/0, no shutdown, and IP address 23.1.2, 255.255.255.0, exit router OSPF 1, router ID 2.2.2, and exit interface range F0/0 and F1/0, IP OSPF network point to point and IP OSPF 1 area 0. Now we will have OSPF neighborship between R1 and R2. Let me configure R3. Do ping 12.1.1. Okay, now you can see neighborship is up. Go to R3 and configure it. Interface F0/0, no shut, and IP address 23.1.3, 255.255.255.0, interface F1/0, no shutdown, and IP address 34.1.1.3, 255.255.255.0, exit router OSPF 1, router ID 3.3.3, exit interface F0/0, IP OSPF network point to point and IP OSPF 1 area 0, interface F1/0, IP OSPF network point to point and IP OSPF 1 area 1. Got it? Now see here, if I will capture this link, is there any capturing? Close it. Interface F0/0, shutdown and no shutdown. I'm looking for router LSA of R1. DVD request description update. Here is the update message. Source IP address is 23.1.3. router LSA. In the router LSA, if you will check what? Flags. Then here you can see B bit is yes. It means router number 3 is what? ABR. Go to router number 1 and check. On router number 1, show IP OSPF border router. What it's saying 3.3.3 is ABR router, area border router. And what is the metric cost to reach ABR?
2.
This is what? This is what? Database of R1. In the database you can see 3 number of router LSA and 1 LSA, 3 summary LSA generated by whom? Generated by ABR router 3.3.3. And what is link ID? the prefix information of area 1. So IP OSPF database summary and 34.1.1.0. What is the metric coming in? LSA 3 1. And who is advertising 3.3.3? What is the cost to reach 3.3.3? 2. So what will be the total cost for 34 network?
3.
3. So IP route OSPF. Got it? How your routers are going to calculate cost for inter-area prefixes?
Sir, so that means OSPF can draw the topology for that own area. It can't draw the topology for the other areas. Like how we can see the numbers of links on the router LSA. Using that, it used to create topology, but it can't create topology for the other routers belong to other areas, right? Because it doesn't have the link numbers of links.
Many times I told you OSPF is a link state routing protocol within the area. Between area it is distance vector routing protocol. Between area it only exchange routes.
Okay. Yeah. Thank you.
Right, and intra-area route will be installed with symbol O, and inter-area route will be installed with symbol OIA. It is inter-area OSPF inter-area. Now let me configure R4 also. Go to router number 4. Interface F0/0, no shutdown, and IP address 34.1.4 255.255.255.0. Exit interface loopback 1, and IP address 40.1.1 255.255.255.0. Exit router OSPF 1 router ID 4.4.4.4 and interface range F0/0 and loopback 1 IP OSPF network point to point and IP OSPF 1 area 0. Now on router number 1, if you will check database again, then you can see
area 1, right? Router number 4 or router number
area 1.
4. You have type area 0, I think so.
Area 1. Now on router number 1 in the database, soon you will receive one more LSA 3 to receive 40 subnet 40.1.1.0. Here you can see, right? So now router number 3 is generating 2 LSA 3 for area 0. Similarly, if you will check R4 database, so IP OSPF database, then you can see 3 number of summary LSA generated by 3.3.3. 1 to share 10 prefix, 1 to share 12 prefix, 1 to share 23 prefix. These are prefix information only. You will on router number 1 you cannot find the actual originator. You can only understand that this prefix is advertised by 3.3.3. These are summary information of prefixes between area, and now 10 and 40 can communicate, right? On router number 4 also you can check what is the matrix. So IP OSPF, so IP route OSPF. See for 10.1.1.0 what is the matrix? 2. How it has calculated 2 matrix? So IP OSPF database. So IP OSPF database. In the database, here is the prefix. Link ID is prefix ID, right, in form of LSA 3. If you will open it, database summary and 10.1.1.0, you can see R3 is advertising this prefix with matrix what? 3. And what is the matrix to reach 3.3.3? 1. So total matrix is going to be what? 3 plus 1, 4. That's why in the routing table, matrix for 10 subnet is 4. For path manipulation, you have to understand the matrix calculation only, right? In EIGRP also, in any routing protocol, if you know the matrix calculation, cost calculation, you can manipulate the path, you can control the path, means you can control the routing, you can configure the routing policies. Inter-area communication done. Now, if here I am going to add one more router. Here now router 4 is further connected with R5, and behind router number 5 I have one loopback. Behind router number 5 there is a loopback 50.1.1.0, and here my routing protocol is let's suppose EIGRPS number 10. In that case, R4 will become what? ASBR, because R4 has one interface in OSPF domain and one interface in EIGRP domain. Let me configure this. Interface F1/0, no shutdown, IP address 45.1.1.4 255.255.255.0. Now router 4 will turn on E bit in their router LSA. What will happen? This is ASBR router, ASBR. So ASBR will turn on E bit. E bit is autonomous system border router in their router LSA. But you know LSA 1 cannot cross area. Router 4 will send their LSA 1 to R3. R3 can understand that R4 is ASBR, but this LSA cannot cross in area 0. Router 2 cannot understand who is ASBR. Router 1 cannot understand who is ASBR. So here your ABR router generates LSA 4 to share ASBR router information. Right? See, this is ABR router R3 knows that I am connected with area 1 as well as with area 0. In area 1 there is one ASBR. Right? I learned that. I know that with the help of router LSA, but router LSA cannot flood in area 0. So router 3 will generate one LSA 4 to share the router ID of ASBR router. It will send to router number 2, router 2 will send it to router number 1. Now your router knows 3.3.3 is ABR and 4.4.4 is ASBR. That's why I told you all odd number LSA, see router LSA, LSA1 used to share the link information, means prefix information. See LSA 2, network LSA. LSA 2 is used to share the attached router information, not the prefix information. LSA 3 is used to share inter-area prefix. LSA 4 is again used to share the router ID of ASBR. Getting my point?
Praphul, can you please repeat that again? You said all odd LSAs?
All odd LSAs are used to share the prefix information, network information. These are what? Prefix. 10, 50, 40, these are prefixes. So LSA 1, LSA 3 and LSA 5. Now LSA 5. LSA 5 will be generated by ASBR router generates LSA 5 to share what? External prefixes in OSPF. And LSA 5 can cross area. It can cross area. So here router number 4 will generate how many LSA 5? How many prefixes are there? in EIGRP domain? 2 prefixes, so it will generate 2 LSA 5. Again, advertising router ID is going to be 4.4.4 and link ID is going to be prefix information 45.1.1.0 and 50.1.1.0 link ID. It will send to router 3, router 3 will send it to router 2, router 2 will send it to router number 1, and router 1 already knows what is the cost to reach 4.4.4. So whatever cost is coming in LSA 5 will be added like with the cost to reach 4.4.4 advertiser router.
Sir?
Yes.
Praphul, it's LSA 5,
It's
right?
normal that you did it LSA 4?
This is LSA
It's
5.
LSA 5, right?
LSA 5.
LSA 4.
Or we are type LSA 4.
LSA 5, external LSA.
What country? So LSA 4 will be only that how to reach the router, that
how to reach
external
ASBR.
ASBR router, right?
How to reach
right?
ASBR.
Just okay.
Router,
LSA 4, right?
yes. Router EIGRP 10 network 45.1.1.0 and go to router 5, configure it. Interface F0/0, no shutdown, IP address 45.1.1.5, 255.255.255.0, interface loopback 1, and IP address 50.1.1.1, 255.255.255.0. Router EIGRP number 10 network 0.0.0. So IP EIGRP interface. Right, EIGRP is enabled on both interface F0/0 and loopback 1. Good. But is R4 your ASBR? No. With the help of so IP protocol command also you can verify the ABR or ASBR. So IP protocol. Here you can see routing protocol is OSPF, no filtering for incoming, outgoing, router ID 3.3.3, and what it's saying, it is an area border router. But on router number 4, so IP protocol, it is not saying I am the ASBR router. Why? Because we didn't perform redistribution. Until and unless you will not redistribute other domain into OSPF, your router will not become ASBR. Go to config T, router OSPF 1, router OSPF 1, and redistribute EIGRP as number 10. Let me capture this link also. If you want to see EBIT, redistribute EIGRP as number 10, subnet for classless network, and here I can define the metric. Let's say I'm saying use metric, first metric type 1, and I'm saying metric value is 10. It will use this metric to redistribute external prefixes in OSPF. That's it. Router 4 has generated one update message. Which LSA it is? Router LSA. In the router LSA, you can see EBIT is on. Means this router is ASBR router. On router number 3, if you will check, so IP OSPF border router, then 4.4.4 is ASBR. If I will take you to router number 1 and so IP OSPF border router, here you can see 3.3.3 is ABR and 4.4.4 is ASBR. How router 1 learn this? 4.4.4 is ASBR. Check database. So IP OSPF database and look for LSA 4. LSA 4 is generated by whom? For 3.3.3 ASBR. For what? To share the router ID of ASBR. Right now in the database you can see external LSA, 4 external prefixes. External prefixes are coming in form of LSA 5 and advertiser router is 4.4.4. 4.4.4 is ASBR, IP OSPF border router, and cost to reach 4.4.4 is 3. And what is the cost coming in external prefix in LSA 5? Like for let's say 50 subnet. So IP OSPF database external and 50.1.1.0. Okay, cost which is coming is 10. You have defined cost 10 during redistribution. So 10 plus cost to reach border router who is advertising this LSA is 3. So 10 plus 3, 13 should be the cost in routing table. So IP route OSPF, check 50 prefix and see the cost value is what? 13. Now you know how OSPF calculate cost for prefixes belongs to intra-area, inter-area and external prefixes. Right? How router 1 knows, so IP OSPF border router, that 3.3.3 is my border router, 4.4.4 is my area ASBR, autonomous system border router, right? So actually router 1 got to know about ABR with the help of LSA 1 and about ASBR with the help of LSA 4 generated by ABR. So IP OSPF database, in the database if you will open this database, so IP OSPF database summary ES summary and 4.4.4.4.
Praphul, can I ask a quick question?
1 minute, you can. Just a router ID of ASBR router. Yes, and now 10 and 50 can communicate. 50.1.1 source 10.1.1. They will not communicate because we didn't redistribute OSPF into EIGRP. So router number 5 still don't have this 10 subnet in their routing table. So here is LSA 1 to LSA 5. One more LSA is there which we need to learn, that is LSA 7. Now if you have question, please ask, bro.
Okay, so is it safe to say that the LSA 5, which shares the external prefixes, can you also say that it's interdomain?
Yes, you can say that.
Thank you.
Welcome. Again I am repeating guys, router LSA generated by each and every router in OSPF domain, but it cannot cross area. Network LSA LSA2 generated by DR router to share attached router information in multi-access network, in broadcast network. LSA3 generated by ABR router to share inter-area prefix. LSA4 again generated by ABR router to share ASBR router information, and LSA5 generated by ASBR router to share external prefixes in OSPF domain. Clear, everyone? Here you need to understand the metric calculation. How all the routers are calculating metric for inter-area prefix, intra-area prefix and external prefix. That's it. Any other question? Anybody?
Sir, when we get the notes will told, right? We get the notes also.
Yes, Praphul, while you are at it, please remember to share the PN file for yesterday and today. I think you were not able to share the PN file for yesterday. Thank you.
Sure.
Sir, I have a scenario-based question if you have time.
Share the scenario.
Can you hear me? Yes, sir. Just a second. I'm sending you a screenshot, okay?
Okay.
So please take a look at your WhatsApp. And if you want to open that screen here, that's fine with me too.
SD-WAN.
No. This is the OSPF regarding. I sent you one screenshot right now, not SD-WAN.
Okay, here it is. Here is your scenario.
If I don't see your screen if you're sharing anything.
Is my screen visible for others?
Yes, we
Okay, I
can.
can see it now. Just a
Yeah.
second, sir.
Yes, bro.
Wow. Okay, here you go. Yeah, I can see it. Sir, if you zoom in a little bit. Okay,
Okay.
so all this is OSPF ring, okay? And
Okay.
if you see every link between the router to the all those layer 3 switches, we have /30. So apparently there is a network that we carved out /24 for the loopback IPs and same network we are using to create links between them. Okay. And then we have another network that we created that we are assigning for those prefixes for /29/30 prefixes based on in devices, how many IPs they are coming across. So you see in OSPF process, I have created all those um, the syntax is there in front of you. So what I'm trying to say here is if I'm running out of /24 network and I don't want to redesign everything and I need to add new network. So I can stretch more devices. I can add more new devices. I'm trying to understand how we can add a new network as a primary, secondary to create new links. If I'm running out of /24, I want to make another /24 and bringing back to the same topology.
I didn't get you. If you are using /24,
Okay, so it's, switch management and point-to-point links. If you see up top left, that first subnet is /24, right? 10.142.246.0/24, right?
right?
So what I'm doing is I'm using that /24 to create a loopback IP as well as point-to-point links between each hop. You see /30, you see there, it's coming from that 246.0 network.
What you want to achieve here? You want to increase number of IP address here between the devices?
No, sir. Um, I'm running out of IP spaces here. Not in this scenario, we do have plenty IPs to use, but
No, what you want
consider
here? Tell me that what you want here.
how I can add network when I'm running out of /24. If
Where
I want to add another
where you want to add?
um, if I want to add 5 more switches or
Okay.
10 more switches to this ring,
Okay.
makes sense, sir? 10 more switches, but then I'm running out of IPs to bring them, bring their connection. Yeah, there you go. There you go, sir. Yep,
Okay.
yep,
You need to
yep.
extend the management IP address, switch management IP address.
But then that's exactly what I'm saying. I'm already running out of the management IP. /24 is already done. Consider that I'm already done using the whole /24.
Then
Isn't
use
I
there
need
a
to add,
problem? Isn't there a
/23.
problem already in the design?
sir, I cannot break /24 and redo /23.
Who is typing? Please put yourself on mute.
That Nagamang, I think so.
Sir, go ahead. Yeah, please.
Yeah, so if you want more
So
IP, use /23.
I 100%. But then for that, I need to delete the /24 and recreate new one, right?
Then use new subnet and perform routing between them.
Okay. Okay, routing
So
between them,
here
right?
you can do
You
one
can do
thing.
the
I
same
don't know
thing.
it will work or not. You can do the secondary gateway in the same interface. You can do that if you
Primary and
running out
secondary.
the IP pool. Yes. So the same interface getting the two IP pools. If you're running out the /24, you can assign another pool in same interface as a secondary, so it will work. But I don't know if the interface is support or not.
I'm thinking, sir, as you mentioned, Basudev, just a second, okay? I'll reach out to you. But sir, what you're saying is if I add network 10.142.247.0, and add that to that into this OSPF process 1, and then create /30 links between those red new connected switches. It will bring all network back to my core router. I will learn all prefixes.
Configure secondary IP address as Basudev said.
That's what I'm thinking too. I was just kind of curious how it's going to interact with all new network, you know.
Okay.
Okay, let me design this process and I'll get back to you if I have any questions.
Yes.
I was trying to understand what is there.